And here we go, I think. Hopefully that transition worked. That was kind of dodgy. I've got a laptop sitting beside me with HDMI out going into a second input on the ATEM, and I was playing a full screen video on it and then transitioned. Hooray! I think it worked. I think it worked. All right. I acknowledge the traditional owners of this land. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Good morning, everybody. And I'm sorry for the late start. I just saw some mention of Project Binky. I haven't watched any Project Binky videos for a little while. It's pretty cool. Hang on. C2 Johns. Oh, right. Yes, that's because on the ATEM it has... I'll just hit that. That should go away. It had picture in picture turned on because I was messing around with it and I forgot to turn it off. Yeah, so Project Binky is a cool project to build a race car and drink lots and lots of tea along the way. I think it's going to be a tea-powered race car. Right. What does ATEM stand for? I have no idea. ATEM, there's probably some background to it, but what it actually is, if that's what the question is a video switching device. So it's got multiple HDMI inputs and multiple audio inputs, and then you can do fades between video sources and those sorts of things. And it does some things really well. It's not a brand, it's made by Blackmagic Design here in Melbourne. So Blackmagic is a company that makes lots of high-end video equipment, and the ATEM is like one of their bottom-of-the-range consumer things. Most of the stuff they make are, you know, like $10,000 devices used by pros. And they make this little thing called the ATEM Mini Pro, which is a tiny little box for a few $100s that is like a super cut down version of one of their like $5,000 video switchers that are rack mounted and used in professional video studios and things. All right, so only one audio. Look for another copy of video running. I don't know what that means. Okay. All right. You have two audio streams running with a delayed sound. I think I know what that is. Just give me a second. I think. Okay. Hopefully that has made that second one go away. Let's see if the audio is better now. I think what was happening was that audio was coming in through OBS, which is, anyway, all sorts of stuff. I'm messing around. I was messing around this morning with my whole video streaming setup, so it's a total mess right now. All right, there should be only one right now. Yeah, I need to do some more fixing. Now, what are we going to do today? I don't know. So, I've been doing a few different things recently. Now, I took my son to the station this morning, which is why I'm late. And on the way back, I was trying to remember, I was talking about something at the end of the live stream last time and ended up going way over time. And Peter decided not to enforce the lunch restriction on the lunch cutoff on me because I was talking about something interesting. And I can't even remember what it was. Maybe someone can remind me of it. Ah, Mako says, can you show it? Probably. Let's see. This is going to be very meta. Now, before I do this, I'm just making sure that I don't have any anything visible, like passwords and stuff. I don't think so. But no. I don't have anything visible. All right. So I have my phone here and it's running DroidCam. I'm going to switch to phone, and now we should be able to see from the phone's point of view. And I'll back up a little bit. There is the ridiculous 49-inch widescreen monitor. there is the, I think that's a 25-inch monitor above it. We got a real Inception Infinity thing going on there. Over to the left, there is the laptop that was running that intro video. Behind that is a monitor that is connected to the ATEM, and it is showing all of the video switcher outputs and audio levels and those sorts of things. And then the ATEM is this little device down here. So it's got 4 HDMI inputs at the back. There is an HDMI output. This HDMI output is what is going to, this is really, really jerky trying to do video through the phone like this. So that HDMI output goes to this monitor, and that is what's showing the video preview and overlays and all of the inputs and things. So this is basically a little video broadcast studio in a box. And it's got, so you take the inputs from all the different things. It's got multiple audio inputs. So at the moment it's got a receiver for my radio mic, and then you can change the levels for the inputs and do mixing and things. It streams directly. It's got an encoder in it. So at the moment it says on air because it's streaming to YouTube, and it's configured with my stream key and all of that sort of thing. So it can do, it can do all sorts of things, like if I hit that, you'll see that I've got, if I turn it on, is that doing anything? Yes, you'll see that I've got 2 videos because it's got picture in picture. I'll turn picture in picture off, and you can do transitions and wipes and overlays and all sorts of things. Anyway, I'm going to get off this camera because it is making me seasick, and I'm sure it is making you seasick as well. So let's get out of that. Now, right. So Mike O'Connor said, are standard camcorders from the last 8 years or so any good as capture devices? No. Kind of. I have my original camera when I started this channel was a Canon HV30. I'm trying to remember the model. It was a long time ago, and I still have it. In fact, you can see it. It is right there on that shelf. There are 2. There's one there, and there is another one right there. There is a Canon HV30 and a Canon HV40. And, oh, Henrik just sent me €2, thank you. Look in Discord, lighting channel, I send pictures. Cool. Yeah, Scott says, I need a camera on top of the 3D printer cabinet. There is a camera inside it. See that, move my head, that gray thing right there, that is a webcam pointing at the 3D printer so that I can watch it in Octoprint. But yes, a camera up the top pointing in this direction, covering the room. I've thought about doing that, and it's the issue is how to get the cabling around and the capture. So what I could do is put an IP camera up there and then capture the IP stream. I didn't intend for this to be a conversation about my streaming setup. All right, Discord. Let's have a look in Discord. And let's see if it opens on the other screen. And hopefully it won't, because that will mess up the OBS preview window. It has opened on the wrong screen. All right, I'm going to change that and then do that and then switch back to there. And it looks it looks like it has killed the OBS preview. Hang on, I'm gonna switch something. All right, I'm gonna go. No, it has killed my front camera capture. I'm just gonna switch to the side camera. Okay, so my side camera is still working. My front camera capture has stopped. I'm gonna kill that and bring it back. Is my front camera going to recover? Yes. Yeah, what I really need is a computer running OBS and nothing else, so that all of the things that I run just on a separate computer, and then that is captured and pulled into OBS. It would make things so much simpler. And it would also fix my Fusion 360 problems, because I was wanting to show you something in Fusion 360 today, and that's going to cause me problems. Now, lighting channel. Let's have a look in the lighting channel. Discord is taking a while catching itself up. And who was it? Henrik said to look in the lighting channel. Where? Old LSC board. Okay. I'm looking for Henrik's pictures. Henrik, as in Henry K in YouTube. Are you also Henrik in Discord, or are you a different user? Because that always throws me. Okay. This has been so random so far. Okay. Grumpy John is grumpy? When am I grumpy? Sparky wants to know when we're going to show the credit card details. Scott says, time for another computer fundraiser. No, it's not. At some point, I will replace the M1 Mac Mini. When Apple brings out a new, like an M1 Max or Pro or M2 or whatever the upgraded Mac Mini is, but this one does me just fine. The problem is Rosetta 2, and the real issue is that a whole lot of programs are not yet compiled natively to run on the M1 architecture, and that includes Fusion 360 and OBS. The two critical things when I'm doing live streams. And because they both run through Rosetta, and the way they do their graphics display, like the way they set up the canvas on the screen, it conflicts. So if you're running OBS and you try to launch Fusion, it usually freaks out and you can't run Fusion 360. I think if you launch Fusion 360 first and then you launch OBS, it generally works, but not always, and it can cause problems in OBS. So basically, at the moment, I can't run Fusion 360 on my computer while it's also running OBS. But apart from that, it's fine. It's good. I use it all the time, every day. So, and I'm very happy with it. It's really cool. So the way around that is to have a second computer, which is running OBS, and I have HDMI output from my main computer being captured just as another video stream, like it's essentially like another camera. And that way I can run all of my programs on the desktop computer and have them captured on the computer that is dedicated to running OBS. So I'm probably going to do some kind of a setup like that, maybe using my old laptop, because my old laptop is an i7. It's a what year is it? It's a 2011? Yeah, I think it's a 2011 MacBook Pro. It's the original Retina MacBook Pro. And yeah, when it's running OBS, it spins its fans and it sounds like a jet engine taking off, but yeah. All right, so Henrik said, photos are big, so I'll have to wait a while. Okay, I have I have Discord open. Oh yeah, what about NDI broadcasting software? Yeah, so I've tried that as well. So NDI is, what does NDI stand for? Something like network blah blah. And yeah, I've used NDI before. I've got NDI tools. I've had NDI tools installed on my old computer when I was using the old iMac. So that was for basically for sharing video over the network. So you can set up an NDI source in OBS and then you share something from a computer over the network using NDI, and then you can capture that video stream into OBS as another input. Yes, I have done that in the past and it was kind of janky. It sort of worked. So anyway, There is no real easy solution to all of this. I just need to mess around with it and experiment more with getting the ATEM Mini working. I think the ATEM Mini will do most of what I want if I get all the macros set up. So what I really need, the big problem I've got is that if I go to, say, picture in picture, and then I switch the location of the picture in picture like that, which I can do through the ATEM, anytime you change anything, it resets the size. So if I customize the size of the picture in picture or customize the location and then I change, anyway, I press a button, it loses all its settings. And also it doesn't turn it on and off. So if, for example, I'm going between the front camera and then I switch to capturing my desktop via HDMI, I want to turn picture in picture on automatically. And then switching back, I want to turn it off automatically. All of that stuff can be done with macros. Anyway, now is not the time to be really talking about that. So, I'm waiting to see these pictures from Henrik. Hopefully they will get there eventually. Yes. Non-disclosure agreement. Yes, Michael. That's what it is. You got to sign the Apple contract. Just 1 second. Okay. I think I need this to clear my throat. Henrik says, look now. Oh, I'm in the wrong channel. That's why. I was in the OXRS general channel. I need to be in the lighting channel. Lighting. So, previously we have had episodes of watch John buy stuff on AliExpress. And then we had, last week it was, watch John do something else. This week it is watch John read Discord. Oh, lighting. There is a lot of stuff in the lighting channel that I have not looked at for a while. Oh, lots of, hang on, I'm going to switch to, where am I going to do this? Switch to screen sharing. So this is Discord. Yeah, yes, it is working. All right, so looking in Discord, this is really cool. Look at this. Very Christmassy lights. And so there's some plastic channel with LEDs in it, mounted up under the eaves. Oh, I see. So the channel is angled so that the LEDs then shine onto this surface rather than down. That's cool. Nicely done. So that is something that Carl S. was doing. Now, where are these pictures? Oh, Maina. Okay. Here we go. So this is a throwback to the conversation from a couple of weeks ago where I was talking about garden lighting. And that was the Watch John Order Stuff on AliExpress episode where I disclosed part of my credit card details and my delivery address. So I went back and blurred that part of the video out later, but I kind of doxed myself. I have a habit of doing that. Anyway, this is photos of the internals, I think, of the of that garden light, the one that I ended up ordering. So this is the interesting thing. Open original. Let's have a look at this. And I'll bring this over here. And, ooh, nice. Can I zoom out? Can I drag it around? No. Why can't I move this? Oh, I can move it. Okay. Okay, so what have we got? We've got a single honking great RGB LED in the middle. And power comes in from there. There looks like a 0 ohm resistor there. Just judging by the number on that. We've got a couple of chips off to the right. Don't know what they are. And there might be stuff on the other side of the PCB. Don't know. Usually for cost saving, these things are done as single-sided loads because doing a double-sided load in a PCB adds to the cost. That looks like the receiver. That's an infrared receiver. It's like an infrared phototransistor. It's got 3 leads and 102 resistor. So that's a 1K resistor. That's probably a bias resistor on one of the leads for this. And then some transistors and other miscellaneous stuff. Alrighty, cool. So it looks like the, down here we've got the 3 leads for controlling the LED. There is the common up here, and you can see that the red lead comes in and goes to all 3 of these. So that's a common anode setup. And then it's being switched on the low side here. So these 3, and in fact you can see these 3 transistors will be the low side switches that control the 3 colors. And so we've got 330 ohm, 330, there's a 120, what is those, 7R5? I can't quite read what that says. 7R, not sure. So we've got 3 transistors down here, and they seem like piddly little transistors, considering that they are switching this LED, which would be doing at 12 volts, it'd have to be doing a couple of 100 milliamps per color. And it's got these tiny little, I guess they're MOSFETs, which will be doing the low side switching. So they'll be like N-channel MOSFETs. I can't read anything on this, so I don't really know what they are. The last picture is better. Okay, so there's another picture. Let's see. And have I missed one? The last bit. Oh, yes. Cool. Okay, let's open original on this one. Bring this back over here. And, oh yes, that's a better picture. Thanks, Henrik. And what I'm really interested to know is what these chips are. Because what I would like to do with this, what I mentioned on the previous live stream, is probably replace the control logic with something like an ESP8266. Now there are a couple of ways I could do that actually. One way would be to fake the input to the infrared phototransistor. So if I did a bitstream recording of commands coming from the transmitter, what I could then do is remove this phototransistor, put something like a WeMOS D1 Mini mounted in the back of this, find somewhere to put it in, and put a digital pin, like a data line from the D1 Mini coming to one of the pins here on this phototransistor. So I'd have to figure out what the pin out is of this transistor, and then do a replay of the infrared signal. So basically fake it. Make it think that it's receiving an infrared signal when in fact it started being sent by the D1 Mini. And then the D1 Mini could... so it'd be the same sort of thing as if you got a WeMOS D1 Mini with an infrared LED on it. In fact, let's have a look at ESP8266 IR Blaster. I've done projects with like this sort of thing in the past. How to make a DIY IR Blaster using a Node MCU board. Cool. So in this case, let's just skip down a whole bunch of stuff. There's a whole lot of software set up. Oh yeah, there's this library, IR Remote ESP8266. So what this allows you to do is receive and capture the signals that are sent by an infrared transmitter, and then you can replay them. So I'll do all of that stuff, and here what you can see is the receiver. So it even looks similar to the one in here. So if we look at this here. So that thing there, it looks identical. Look, it's got the little dog leg on the pins and everything. So this infrared phototransistor could actually be something like a TSOP1738. And what you can see here is that it's got a connection to ground, a connection to 3.3 volts, and then there is the output from it, which is going to the data pin. So D5 on the node, on the node MCU board, and then you load the code, and then you point the remote at it and you press a button and you get this coming out of it, and you can record the raw data. So you can capture the hex codes, and then you can send those same hex codes later if you want to control it. So what we've got here, I think this would actually make an interesting project to do a video about. So what we do here is the opposite of it. So we're doing the IR blaster side. So it's got an infrared LED and a transistor. It's got a 2N222 in this case, which I think is just a what is a 2N222? I think it's just like a basic NPN transistor, like a BJT. I can't remember. Then one of the other examples is the transmitter side of it. I'll just blah 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 through this, zippity doo, because I don't want to spend too much time on this right now. And then you can, basically the point of this is that you are capturing the signals that are sent by the infrared transmitter and recording them, and then you can send those signals whenever you want. So what I'm proposing here in my kind of roundabout way is building a circuit like this, except that instead of putting in the transistor and the infrared LED, I would just take the data, so where we've got here going to the base of the transistor, we've got digital pin 2. So D2 is the output pin, and it might need an inverter, so it might still need a transistor in there. But the idea is that you would take the output that you would be using to drive the LED and connect that digital pin directly to the pad here that the output of the receiver comes from. So it's like being an IR blaster without any infrared. Just drive the data straight into the receiver. So that's probably the minimally invasive way to take control of this device. Yes. I haven't been looking at the chat, but I just saw Scott Miller said, Ralph Bacon recently learned not to trust libraries while building an IR controller in Arduino. What's that about? I haven't heard of Ralph Bacon. Is this someone I should know about? And is there a link? So, Scott, if you can drop a link or something in that, that would be really, really cool. Mr. Fixit says, have I seen the device that turns an IR blaster into a radio blaster by replacing the batteries in your IR handset? No. That sounds interesting and curious. Oh, okay, so Dodgy says, before I get lost in squirrels, you're going to talk about Shelly PM4 Pro from last week. Yeah, there's nothing really to add to that. I haven't heard anything from Altico at all. So, okay. Just search for the name and IR controller. Says Mike. Okay. So who am I looking for? I've lost that. I've lost that. It scrolled off my screen. Where is the name? Where is the name that I need to look for? Yeah. Following the traces, the first SOIC chip is doing the IR receiving, and the second one is controlling the MOSFETs. That'd be my guess. So that's what Austin's Creation said. Yeah, so my guess is actually that this chip here is most likely a I think it's from NatSemi, the WS2811, or if they were going really old school, something like a WS2809. So that is a low side RGB PWM controller, which is addressable, and it's the chip. So if you get a WS2812 series chip, you know, the little addressable RGB LEDs, That is a regular RGB LED with a driver chip inside it, like actually physically inside the package. And the chip that they put in it is the same core that is in the WS2811. So that is probably just a WS2811 with its outputs coming down through here. You can see the traces coming through. In fact, let's hang on. I'm jumping around here. Ralph Bacon. All right, I am going, before I get into that, I'm going to look up Ralph Bacon IR Blaster. And, forget buttons, use infrared. All right, let's go. Let's go, Ralph. I'm going to come along to this channel and hit,
This is my channel.
I'm going to stop that, I'm going to hit subscribe, and I'm going to leave that open and come back to that later in the day. So, what was I looking for? Okay, just to see if that is a WS2811. WS2811 pinout. I use these chips on a few of my devices. They're really cool. So this is the pinout. So we've got out red, out green, out blue, and that is starting from pin 1. So if we come back to here, pin 1 is there, and we've got 1, 2, 3. That does not match up with my expectations. And what have we got on this side? So we've got pins 6 and 7 are the ones that come down here. Pins 6 and 7 are D in and set. So that does not look like what I expected. So it's quite likely that I'm wrong. I often am. So that may not be a WS2811, because the other way to do this would be to simply take control of these transistors directly. So that would be probably not as cool. I kind of like the idea of removing the photo transistor and sending IR codes directly into that digital line, just for the hell of it. It would be kind of funny. And of course, the other thing is that if you're talking about really minimally invasive, the other way to do it would be to actually make an IR blaster and physically mount it inside. So you can see here that this receiver, I don't know about the mechanical construction, but it looks to me like this is sitting in a slot in the PCB, which means it is probably exposed on the back side as well as on the front side. So if there is enough room in here, I could possibly just make an IR blaster, stuff it in the back, and have it transmit IR and control the lights. That might work. But yeah, I do like the idea of faking IR codes and sending them straight into that pin. We'll get to that. So, okay, in order of least invasive to most invasive. Least invasive would be make an IR blaster and physically stick it inside the case somewhere. Next is make an IR blaster without the infrared LED and send the output directly into the pin here. So override this receiver. Next most invasive would be if this is actually something like a WS2811, then cut the track that is its data in and send data to it directly. So that way what you could do is use something like the Fast LED library or Adafruit's NeoPixel library, run it on the ESP8266, and just treat this whole thing as if it's a single NeoPixel and just drive the WS2811. Now that is if this is a WS2811. I don't know if it is. And those pins don't seem to match. So, yeah, I can't see where that one goes. Or maybe that one goes to there. What is pin 5 on here? D out. Yeah, the pins on the WS2811 really do not make sense looking at this. So I suspect it's not a WS2811. And my initial guess was wrong. So, yeah, if it is WS2811, cut the data in track and feed data to it directly. Now, if that fails, working back along the chain, the next thing to try is whatever is controlling these transistors. So you can see there's a trace that comes There are traces that come down along here, and it's probably 1, 2, where is the other one being controlled from? I don't know, it's probably the other side of the PCB. If there's there might be a via or something here. So, or is that it? No, that looks like it's a ground plane. Anyway, the point is, find the tracks, cut them, and use 3 outputs from the ESP8266 and drive those 3 transistors directly, and then they can be PWM'd, you can do, you know, color blending and all of that sort of thing. So that's another way to do it. Just drive these transistors. So looks like there are plenty of options, and even the most invasive ones aren't that particularly difficult in terms of modifications to the board. Provided there is physical space to put something else in the back of this, like a D1 Mini or a tiny Pico, which is significantly smaller. So the Xeon's tiny Picos are, you know, you need a microscope to see them. They're so small. So what we could do is put something like a tiny Pico in there and run wires through and connect it in one of those locations. In any case, I'm pretty confident that I can take control of this. I should be able to do something that will allow me to link it in via Wi-Fi and have control of it. So that should be pretty cool. Now, I am going to have to go at the normal time today. In fact, I'm going to have to go pretty much on 12 because I have a commitment after this live stream as well. So it's going to be a short live stream today. Now, what are we up to? Henry keeps sending me €2 comments. Is that just a way to get my attention? Because I just scrolled back down through the chat messages and I saw another €2. So Henrik's latest comment was, it remembers the function, so maybe a memory chip. Yeah. Right. Yes. Oh, Johnny said, Johnny has linked to modifying, hang on, what sensor is it using? This is getting slightly off topic, but this is the air sensor. Hang on, opening another window here. All right. Air sensor? That did not seem to be the most recent one. Let's try the Hackaday link. Okay. Yeah, so is this the Tradfry thing? Where is it? Yeah, the how do you say this? IKEA Vindritkning. It's a $12 sensor. Yeah, that does, I think it's got a laser scattering sensor built into it. So this is a, yeah. The fan speed change is part of the sensor's cleaning cycle. Disabling is eventually going to, how about, yeah, okay. Hacked an ESP board so I can broadcast sensor readings. Yeah, similar sort of idea. This is quite a fun sort of project and concept in general. Taking something that is like a standalone device, and this is the sort of thing I've been doing for as long as I can remember. Taking a device which is intended to be standalone, and then you hack some microcontroller inside it so that you can either take data off it or you can send commands to it, like simulate button presses and control it over a network. And that is exactly what I'm talking about doing with this. Taking an existing garden lighting system and putting an ESP8266 in it so that I can control it over Wi-Fi. And where were we? And this is taking a standalone air quality sensor, which it takes readings and then it changes its color. So it gives you warnings when you've got a bad environment. Oh, Johnny says, Vindricting, I don't know why, but my brain is just, it blanks out on that word, Vindricting. I think that's it, means wind direction. Yeah, So, yes, and as Scott says, like the original Steve board for the UT61E. Yeah, take something, add a microcontroller to it, and make it more useful by giving it some connectivity. Wind drifting. It even sounds like, now that I know that it means wind direction, it even sounds like that. Vindrichting. Vind for wind, and richting for direction. Vindrichting, wind direction. It makes sense. Yes. All right, now, where are we going? Where are we going? I don't know where we're going. I think I need a drink once again. Dodgy says, I wonder if that would work on the new smoke alarms. Adding, okay, a warning. Modifying smoke alarms that are required by your building regulations will probably render them non-compliant. There is your warning. Beyond that, yes. So up in there, now when we had this house made, building regulations in Australia now require you to have mains hardwired smoke detectors in certain locations. Like they have to be within a certain distance from the doors of bedrooms and those sorts of things. Anyway, there are rules about it. And when we did this big renovation, we had new smoke detectors put in throughout the house. They're all hardwired and they are linked together, which means that if one smoke detector goes off, all of them go off. And sorry, I was just distracted because Henrik keeps sending me €2. My last €2 today, watch again in DC, I sent new stuff. Okay, I will check in Discord. Thanks, Henrik. So when one smoke alarm is triggered, all of the smoke alarms make noise. So if you've got a smoke alarm in a distant part of the building and it's going off, maybe it's at night and you're deep asleep and it may not wake you up. So if the smoke alarms throughout the building are activated, then it'll wake up everybody everywhere. Anyway, there is a smoke detector right there inside the enclosure for the 3D printer. And I just went down to Bunnings and I bought a cheap smoke detector and I stuck it in there because I was getting a little bit paranoid, and I have had one heated bed catch on fire. Well, when I say catch on fire, it caught on fire to the extent that the connection of the cable where it comes into the bed, and because the bed of the printer moves, the cable flexes, and the joint where it attaches to the bed got frayed. It ended up high resistance and it got stinking hot and burned through and actually went open circuit. And so the heated bed went cold and the controller detected thermal runaway, which is when it is trying to run the heater and it's trying to heat up, and it's not, the sensor is not showing it that it's getting any hotter, and there's a safety thing in it that says there is either a problem with the sensor or a problem with the heated bed because it's not behaving the way it's expected to, it's not responding to the power being applied to it, and the printer goes into a safety shutdown mode and it turns itself off. So that's what happened, but it was probably only, I'm just thinking about what would have happened with that. No, that situation would not have caused a fire. If the printer had failed to detect it, it would have kept printing. It's just that the bed would have gone cold. That would have been the only danger. But then with the wires sort of moving around, maybe there would have been some arcing. I don't know. Anyway, when that happened, I became a bit paranoid. And so, hang on, let me just switch to front camera here. So right there, you can just barely see it. There is a smoke detector mounted inside the enclosure. But that smoke detector is not connected to anything. It's not connected to all of the rest of the smoke detectors in the house. I'm sitting in the lab right now, which is behind the house, behind the garage. If I leave a 3D printer running here and it catches fire and that smoke detector goes off and I'm in the house, I'm not going to hear that smoke detector. So being able to send stuff from that, like broadcast a signal saying that it's gone off, that would be a really, really useful thing. And I have been thinking in the past that what I really should do is open it up and stick something like a D1 Mini inside it and have the output, the output of the smoke detector, which goes to the piezo element or whatever it is that makes all of the screamy noise and blows your eardrums, basically detect that and use that to publish to MQTT. So there is an event that happens when the smoke detector goes off. And then that can be used for whatever purpose. Like you can have it raise alarms elsewhere in the house, or send me an SMS or an IM sort of notification or whatever. But yeah, adding a device to the smoke detector. However, there is a power issue. It would need to be powered, and the smoke detector at the moment runs on battery. So there is just a 9-volt battery in it. There's nothing else connected to it. There's no power cord going to it. And having a device that needs to run for a very long time and connect to Wi-Fi could be a problem. So another way to do it would be to use something like a Zigbee device. So here we've got, this is a Zigbee door sensor, and I already have Zigbee coordinators around the place. I've got 3 Zigbee coordinators in the house. And so what this one does is, this is a Zigbee transmitter, and it's got a reed switch in it, and then this is a magnet that goes on the door. So as the door opens, the magnet moves away, and this then transmits a signal over Zigbee saying that the door has been opened, or the switch has been opened, and then it sends another signal when it's been closed. So probably an interesting way to do it would be, instead of putting something like an ESP8266 in it, get something like a Zigbee sensor. These are, what are they? The Aqara. Yeah. So these are Aqara range Zigbee sensors. Open this up. I've been meaning to do a video about this as well, because I've done this and it's actually really, really cool. If you open, let's switch to overhead camera, and it's from when I was messing around with the pick and place machine yesterday. Oh, this is something that I'm making a video about right now. This is an adapter mounting bracket for a laser diode. So this bracket screws into my laser cutter in place of the lens mechanism in my carbon dioxide laser. These holes are the same mounts as the existing head, and then this screw, it's got heat set nuts in the back here, and then this screws into that using some M2 bolts, and then a laser diode assembly goes on that. So that's a way of retrofitting a laser diode into my K40 laser. Anyway, that's a whole other subject. Let's get this open. So this is, come on. Oh, I'd have to pull it open more to get into the guts. So taking the back off, you can only get to the battery. But inside here is a reed switch. A reed switch is just a magnetically activated switch, and that is why when this comes near it, which side? That side. When this comes near it, it activates the reed switch. So what you can do is open these up, unsolder the reed switch, and then you have a battery powered transmitter that'll run for like a year or 2 years on a single coin cell battery, and that will transmit events when that input is triggered. So what you can do is then you take a couple of wires out from that where the reed switch used to be wired, and you can then trigger it with whatever you like. It could be triggered using say a reed relay. You could have a reed relay output wired across where the reed switch is, and then the input to the relay could go to something else like the smoke detector. So that way, whenever the smoke detector is activated, the read relay would fire, and this would receive a signal, and then it would transmit, and then your automation system could deal with it. So yeah, that is a fun little project as well. Yes. All right. So Martin Visser, all shiny, and John is distracted. Yes. Now, I got another €2 from Henrik in order to make me look at Discord again. So let's go back to here and let's see. All right, here's a little project I want to show last weekend. Okay, easy EDA. Ooh, hang on, let me just back up a bit. Arduino Mega inside weather station shield. Okay, open original. Let's have a look at this and zoom in. What have we got? BH1750. I have no idea what that is. I assume that that pin is not meant to be soldered. So we've got an ESP01 module, an ESP8266, and there it's in a Mega form factor, so it goes onto an Arduino. Looks like a USB socket there, a reset button, and a display, and something loops down. Oh, okay, that's a connection for the display. Is that another USB socket? Is that two different types of USB socket? Looks like it might be. USB-A, maybe? I don't know. What have we got? BMP180. So that's a temperature and humidity sensor, or is it atmospheric pressure as well? I can't remember. So that's an environmental sensor module. And yes. Michael says, I think John is being trained Pavlov's dog style to look at Discord. Yes. Each time someone sends me money, I look at Discord. Yeah, the outcome of that, if that works, Michael, the outcome is that every time someone sends me money, I will just look at Discord as a reflex. Okay. Cool. So, interesting environmental sensor. Yeah. Yes. Oh, David Howe said, I've used those for a mailbox sensor with a micro switch and a tipping bucket type rainfall sensor. Nice. Yeah, that's very cool. Oh, Johnny says BH1750 is a light sensor. Oh, right. Okay. So we're getting light level, and we're getting some atmospheric information and a display. So what I'm curious about is why this is in an Arduino Mega form factor with an ESP01 on it. Let's see what other clues we can get. And, or we could just have a look at here. Look at this. Easy EDA. Arduino Mega inside weather station shield. All right, so it goes onto an Arduino Mega, and what do? Yeah. All right, so my question is, why is it in a Mega form factor? Is it using an Arduino Mega as well for something? And then using the ESP01? Maybe it's just using the ESP01 so that the Mega can read the sensors. I should be able to see it from here. Open in editor. Let's see. Do I have an account on this? I don't know. All right, so it looks like, so we'll have a ground connection, we'll have a, where's 3.3 volts? Is that 3.3 volts? Looks like it is. Okay, so that is 3.3 volts. And then, what have we got? Connections to Yeah, just using the ESP for Wi-Fi. Yeah. Oh, Scott says ESP1 was originally designed to act like a modem for Wi-Fi connectivity. Yes, that's right. So that's what I'm just trying to find here. So there should be... Where are the extra hardware serial ports? It's there and there. Okay, there it is, yeah. So that... But why does that come to there? On the Arduino Mega, the extra serial ports are up here. Now, how do I use this program? Can I zoom in? I can! Hooray! Now, how do I pan? Can I drag? Double drag? No? 2 fingers just zooms. Oi, no! Sorry, I'm not trying to change anything here. I just want to move this thing. Is there a tool that I can use? View, zoom, is there a... okay. Maybe it's a bit like KiCad and there is no just grab and pan tool. Oh, hang on, no, what's that? PCB tools, there it is. No, that's for moving stuff. And you got to zoom out and zoom in. That is actually one of the things that drives me nuts about KiCad. The fact that you can't just scroll sideways in designs. You have to zoom out. You got to relocate yourself, zoom out, relocate yourself, and zoom in. To when all I want to do is click right there, drag sideways, and just move my view a little bit. Anyway, yes. So that I'm pretty sure these connections are serial. Yes. Oh, the embedded hobbyist says, up a bit late, so I thought I'd check out the stream live. Welcome. Thanks for coming along. Right click maybe and hold. Let's see if that works. Oh yes, right click. That is the magic. Haha, thank you. So just going back to here, and it uploads data into ThingSpeak. Ooh, nice. Hang on, I already had that open. I've got to switch back to here, there. No, not there. There, yes, there. All right, so there's a resistor there. Yeah, it is TX and RX. Oh, Aaron says, John, given this is your last stream of the year. What? No, surely not. Are we that close to Christmas? What's your top project from this year that you're proud of, and what project do you most want to achieve in 2022? I don't know. I'll have to think about that. Okay, so yes. Before I go off on that tangent, I just wanted to say thank you for sharing this project. Going back, yeah, Henrik, thank you for sharing this project. This is cool. And yeah, the fact that you got photos of, I'm gonna close that. The fact that you got photos of the real thing shows that it's not just an idea, you've actually built it, which is awesome. And it pushes things up to ThingSpeak. All right, now, no, I didn't not want to save that change. Yeah, close that. Now, projects. I've got a couple of things I could show you. One of the reasons that I was messing around this morning with getting the ATEM Mini working and messing around with my other laptop to be able to feed into it as a second source was so that I could use Fusion 360, because I wanted to show you my PCB conveyor project. And what will I show you? I'm going to grab some stuff here. And also tool changer, which I'm going to add to the KO pick and place machines. Now, yes, chucking stuff on the bench so I can show you. What have I got? That. Let's go to overhead camera. overhead. Okay, then what else am I looking for? I want one that's open, linear rails. This one, this is the open linear rail. Let's take that one away. That's a nozzle holder for Juki nozzles. And I don't have any Juki nozzles in here. I have 60 Juki pick and place nozzles out in the garage, so I can go and grab some. Now, what is this all about? What is going on here? Oh look, there are multiples of me. How has that happened? Oh, it's because I've got the overhead camera and the front camera and the side camera. So I'm going to turn off HDMI front camera. That one can go away. Oh, and I've got this, which is a nozzle changer mechanism, and this slides along like that. So I've been having pick and place fun recently, and I've also been rebuilding my laser cutter. That's another thing. So this is messing around with an idea for a conveyor belt system to link the pick and place machines together. Because the problem is that the output of the pick and place machine, so the KO pick and place machines have conveyor belts in them. And you can feed a board in from one side, it does all the placements and then feeds it out again. And it has ready in and ready out signals so that you can chain devices together. And the conveyor belt stops until there is a matching ready in and ready out on the two adjacent machines, and then both conveyor belts start at the same time, and then it moves stuff along. So what I've been looking at doing is designing a conveyor belt that has an automatically adjustable width. In fact, what I'm going to do is I'm going to jump across to my laptop and see if I can launch Fusion 360 on that, because then I can show you that screen. So yeah, the idea is that I've just been messing around with some ideas for making a conveyor belt, and I've got some GT2 timing belt. This is a continuous belt, and the idea is that it goes around it like that. And this is not cut to length yet. This is just a scrap piece of aluminium tube that I had, and it was short, so I just grabbed it. So that's why the belt actually doesn't go to the end. And then there is this piece, which has the wheel on it with an N20 motor in it. And if let's fire up the power supply. And where am I going? Power supply. I need a power supply. I need a lead with some alligator clips. Maybe that one, that'll do. So which one am I on? Power supply 2. It's set to 12 volts. Yes. And the idea is that if this tube was cut to the correct length, this would be inserted in the other end, and then that would go around it. So imagine that the tube was actually cut to right about there, and then this was inserted in the end. And then there would be a little tensioner that, like a spring-loaded tensioner, that comes in and pushes on this to keep it tensioned up. But I don't have the tensioner mechanism there, so I'm just going to grab this. I can't even get the whole thing in the field of view. So grab that, and power supply, I'll chuck that on there and hit go, and the belt is running. You can probably just see there. Oh yeah, you can see the mark there on the timing belt. So that will be a conveyor belt, and there'll be two of these. So one on the front side like this, and then a mirror image on the back, and the PCB will travel along on the conveyor belt between the pick and place machines. And there'll be a sensor so it knows when the board has arrived. That's kind of loud and annoying. So yeah, it'll have a sensor so it knows when the board has arrived, and the sensors for that are somewhere around here. They're in the box. And then the front rail will be mounted. Fusion 360 wants me to sign in, so I'm just glancing across at my laptop. So I'm not going to bother with that. But I've got this pretty well all designed out in Fusion 360. So the front rail will be in a fixed position. Oh, and also when this is in the correct location. If you're looking down on it from the top, you can see that there is an overlap there. So the PCB will sit on top of this timing belt, and it will be constrained by the edge of this square section. So it will sit, if I grab a PCB, it'll sit like that. The edges of it will sit again, and then it will slide along the inside here. Although there'll be just a little bit of clearance, and that should be okay. So there'll be another one of these mirror image on the other side. Now the front one will be in a fixed position. The back one will be adjustable, so it moves backwards and forwards depending on the size of the PCB. So that is what these linear rails are for. And these little CN7 or whatever it is, oops, I don't want that to fall off. These little CN7 rails will be on the frame running front to back, and they will slide like that. So this will be mounted on two of these, one on each side, and it will slide backwards and forwards to adjust the width of the conveyor belt. And then there'll be a stepper with another timing belt and like a homing switch, so it can home itself. And the idea is that I want to be able to send a command to it to tell it what width it needs to be. Like say I'm running a 50mm wide PCB, then when the pick and place machines are configured and I tell it what size PCB is being loaded, it'll automatically adjust the conveyor belt in the pick and place machine, and also adjust the external conveyor belts that link the pick and place machines. So yeah, if I say I'm loading a 50mm PCB, I'll have this move so it goes to like 51 or 52mm or something, whatever ends up being a reasonable clearance for that to be able to move nicely down there and not fall in the hole in the middle. So the conveyor belt will go and automatically adjust its width, and then PCBs can be fed along it. So I'm going to need a little G-code type controller that goes in there. Oh, and this is the nozzle changer I was talking about. So this is for changing nozzles in the pick and place machine, because the KOs do not have nozzle changers. You have to manually put the nozzles in. I'm going to go for a little walk. You'll be able to hear me but not see me. A little walk out into the garage because I need to grab some nozzles. I've got a wheeled cabinet out here which has heaps and heaps of nozzles in it. And then I can check out how they fit into this little adapter. So this thing came from Delta Printer. I'm not sure where they are, but anyway, this tool changer is actually intended for use with their Rapid Star pick and place machine. And you can buy all the different parts for their pick and place machine individually, so I just bought the tool changer. This is a small one. How many is this? 10. So this is a 10 nozzle changer. They also make the same thing but in a 20 nozzle version, which is obviously twice as long, minus the extra bit on the end. So for pick and place nozzles, what happens is you load a bunch of your nozzles, all the different sizes, and have them indexed so you know which one is in which slot. And in normal use, is it going to move? What have I done wrong? What have I done wrong? Have I jammed something in here? Oh, I think I hadn't put one of the nozzles in properly. Okay, so in normal use it's like that. And these are fixed, so they can't come out. And then this is the nozzle holder that is attached to the pick and place machine. And it's got little retention ball bearings in there, which are held in by this rubber thing. And the idea is that this is a press fit. You can see the collar on here. So normally what happens is that manually, when you want to change nozzles, you grab the nozzle, you pull the old one out, and it just clips in and out. You can see that you push it in, it goes in, and then it's accurately indexed so that there is minimal run out. and run out is eccentricity. So as this rotates, you want the nozzle tip to remain in the same position. It can't, wander around, and you can just pop it out. Now the way this nozzle changer works is you have a nozzle loaded, and the machine, I'm going to try doing it sideways so that you can kind of see. Imagine you're looking at the machine from the side. So the nozzle comes along and it goes to a clear location and it descends into it, and then a motor, which gets mounted under here, pulls this across, and that locks the nozzle in place, and then the machine just retracts the nozzle. Well, it tries to retract the nozzle in the Z-axis, and it pops out. So then it comes along, goes to the nozzle that it wants to load, descends onto it, it locks into place, then the mechanism opens and it lifts it out. And when it wants to unload, reverse the process. So this is a really cool little mechanism for loading and unloading nozzles automatically. And yeah, as I said, it's intended for their rapid star pick and place machine, but I'm going to use this mechanism and adapt it to go onto the KO A4 pick and place machine. So the KO has it can have 4 nozzles loaded at once. It's a single head 4 nozzle machine. And that is kind of annoying that you can't do automatic changes, because often what you'll want is to have, say, 4 nozzles the same loaded for, say, 0603 parts. And you want to be able to load a whole bunch of 0603 parts, but then at some point of the job you want to be able to load maybe an IC, so then you pull in a bigger nozzle, and then one of the nozzles might get swapped for a larger size, or you might want a smaller one, or for 0402 parts or whatever. So it's got all these different size nozzles depending on what you want to pick up. And with fixed nozzles, you're kind of limited. So normally what would happen is that people would leave a couple of their most common nozzles loaded, like say 2 nozzles that will do 0603 parts in my case, and then you might have 2 other nozzles loaded, like a large nozzle for larger ICs, and then you might have a nozzle loaded that'll do, like, I don't know, capacitors, or like larger capacitors, or WS2812s or something. So you end up with a mix of nozzles loaded, but that mix is not always optimal in terms of the job. So being able to change nozzles is really important. And with this mechanism, I should be able to mount this inside the frame of the KO and program it so that I can load and unload nozzles. Now the factory software can't do that, but OpenPNP can. So I'm going to be retrofitting OpenPNP, I think, onto the KO. That's my plan anyway. Don't know if it's going to work. So, and this other belt. I'm going to make 2 different types of conveyors. One is going to be a little linking conveyor, and that's going to use these short belts. So this is going to be a short, where can you get an idea of the length of it? Don't really know. Yeah, so you can get, this will be a short conveyor that will only be used for joining between 2 pick and place machines. It's going to be about 300 millimeters long, about 280 millimeters long. Basically long enough that the machines don't end up jammed up hard against each other, because their own conveyors don't really protrude very far. They just sort of end at the end of the machine. And this way I can daisy chain the pick and place machines with a 280 millimeter gap between them, which is enough room that you can reach in if there are any problems, like boards coming out of one machine into the next, or you need to do something on the machine. You don't want them jammed up hard against each other. So this will be a little transitional conveyor belt. But then this is the conveyor off a rapid star pick and place machine, and it's longer. How long is it? I think it's about 800 millimeters or something when it's doubled over like this. So what I'll do is use this longer belt to make an inspection station. So when PCBs come off, it's pretty common on SMT production lines that when PCBs come out of one machine, you might have a station which is wide enough for someone to sit at, and typically there is like a small bit of bench area in front of them. And so the PCB can come in on the conveyor and you can pick it off the conveyor, put it down on the bench in front of you, do inspection or rework or manually loading parts before it proceeds. For example, if you want to load parts before it goes through the reflow oven and you need to do it manually, what you can do is have this inspection station where the board stops in front of you, you take it off the conveyor, put the parts on by hand using tweezers or whatever, put it back on the conveyor, and then it continues along. So that conveyor needs to be wide enough for a person to sit there with some tools. And that is what this bit of belt is for. It's wide enough that I can sit comfortably and I could have a machine on each side and a bit of working area in front of me. So one of the projects that I'm going to be talking about in the future is building this conveyor system. It's one of those things that, building a conveyor system sounds like it should be really simple, and it's not really that complicated, but there is a lot more to it than you might first think. It's not as simple as a couple of belts and a couple of motors. You need ready in and ready out signals. You need the motor controller. It's going to need the Y-axis auto adjustment for the width, and there is speed control, and yeah, it just keeps going on and on. It's one of those projects that I thought I'll have this done in no time, and then I started designing it in Fusion 360, and it just kept becoming more and more complicated the more I got into it. Alrighty, where are we at? Aha, Johnny says alert 3 minutes. Okay, we are getting down on time. Oh, Scott says technically he has 4 PNP machines. Yeah. Yes, technically I do. So I've got 3. Now, I actually decided that I would never admit ever that I had more than 2 KOs. I bought 2, and it's machine 0, machine 1, and machine 2. So I've got 2 KO pick and place machines. And then I've still got Mickle Make It, which is my existing pick and place machine. So one thing I have actually been thinking about, and I was thinking about this before getting the KOs, was retrofitting a conveyor belt onto Mickle Make It so that I could just feed PCBs in, have them move in, stop, do the job, and then feed them out at the end. But yeah, there is a geometry problem with it. There is a drag chain on one side that runs exactly through where the boards would need to pass. So that would be a real problem. I could fix that by relocating the drag chain. I could move the whole thing down lower. No, I'd have to move it up higher. It could be done, but I don't think that's really all that relevant now once I've got the KOs up and running. Now, Johnny says, urgent alert, 3 minutes. Oh, Mr. Fixit says, where can I buy the nozzle changer? Okay, that is actually a really important thing. So I am going to take you to SMT assembly. Oh, and the other thing is that this same place, so Delta Printer are also about to release some electric feeders. And I'm going to try to retrofit these electric feeders onto the KO. All right, this is the Nozzle, they call it the Nozzle magazine. 1 minute warning. Okay, so this is the nozzle holder mechanism that I just showed you. And, in fact, why don't I've dropped it into the chat, but I will also go to desktop view. So this is it on Delta Printer, without an E in the printer.com, and this is their nozzle changer for their rapid thing. Medium or large? It's like takeaway places that that have 3 sizes for their drinks: large, extra large, and super sized. just call them small, medium, and large. All right, so yeah, medium and large. I got one of the medium because I was thinking of fitting this onto Mick or Make It actually. I'm not sure if I'm going to end up fitting the 20 nozzle or the 10 nozzle version onto the KOs. It's I don't really know how much clearance there is, and because I don't have physical access to them right now, they're at Lachlan's factory. I can't just walk over and measure stuff and figure out where things are going to fit. And yeah, if you are playing around with pick and place machines, check out what Delta Printer have, because they have some cool stuff. They do these nozzle holders as well. I've got 2 of their nozzle holders and also a bunch of the KO nozzle holders, and their vacuum sensor board, I've got one of those. Rapid feeder mini main board. Oh, and this is the conveyor board with the sensor. This is where they, like the SMT conveyor belts they've got here. And check these out, rapid feeder. This is what I'm really excited about. And these have been coming for a while. Look at this, it says pre-order only, ships 2021. They're actually not quite ready yet. But these feeders look like they're going to be amazing. They are electric feeders that will be quite capable of doing 0402 parts, and I think in testing they've also got 0201 working. And they are only, where is it? If we go to 8mm feeder, yeah, it's $59 US, which is amazing. And they're very compact, so it doesn't mount the reel directly on the feeder. The reel has to be mounted separately. But they are pluggable. They've got QR codes on them. So what you can do is load a bunch of feeders and have your machine auto-detect what you have loaded. It can use the down camera on the head to move along and scan all of your feeders and go, I've got 10K resistors and I have, 100 nanofarad capacitors, just by scanning all the QR codes, which it then looks up to match to what those QR codes are. So very, very cool. -2, okay, I am going to have to go soon because I've got to take my daughter somewhere. So these things, like basically these are equivalent to something like the Yamaha electric feeder, but the Yamaha electric feeders are like $250 to $300 US, and these are $59. So that price there, the $1,399, that's for a pack. Like if we go to value pack, the value pack comes with the motherboard that controls them, 19 8mm feeders, 3 12mm, 2 16mm, and a 24mm feeder. That is a big set of feeders that will do most things for $1,400. So yeah, these things are really cool. And they've been developed in public on the OpenPNP mailing list. So Shai, who has been working on these, he's been posting photos of internals and all of their progress of designing the mechanicals and how it works and the problems that they face doing it. So yeah, I'm really excited about these rapid feeders. I want to buy these once they come out and retrofit these onto the KOs, because it'll give the advantage of the electric feeders without paying $250 each for like Yamaha electric feeders. So, all right, I am going to have to go because, as Scott says, never disappoint a daughter. All right, now first I'm going to, getting out of this live stream is now going to be a bit of an exercise because of the way I've got this set up with the external thing. So hang on, I've got to stop that. I've got to full screen that. And now, how do I get out of here? First, front camera. All right. I'm lost. How do I get out of this live stream? First, thank you for coming along. And sorry I'm rushing off like this. I've got so much to talk about, so many projects, but I am going to, hang on, I've got to hit play on that. I think that is playing now. And I have to switch to it. Bye.